Today's notes are on arithmetic or arithmetic sequences. And what an arithmetic sequence is just a pattern of numbers. And the way you can identify and generate arithmetic sequences, the trick is to kind of defining it as arithmetic, is we're going to have to add to get our pattern. So when we have a sequence or just a bunch of numbers together, we need to add to get a pattern in order for it to be arithmetic. So I think of A for arithmetic or arithmetic, you can say either way, is adding to get your pattern. So if you look at number 1, they say, is the following an arithmetic sequence? If yes, state the common difference. And the common difference is what we're going to add to get our pattern. Okay, and we're going to see down here, if you kind of want to, okay, your D is going to equal your common difference. So D is going to be the number you add to get the pattern. If it's not the same number for every single term, then it's not going to be arithmetic. So if you look at 2, 4, 6, 8, I add 2, I add 2, I add 2. So yes, that is definitely an arithmetic sequence, and my common difference is 2. Take a look at number 2. I subtract 4, I subtract 4, I subtract 4, I subtract 4. Even though it's subtracting, it's like you're adding a negative 4. So I'm going to say my common difference is negative 4, and there is a pattern because I'm subtracting 4 from each term to get the sequence. On number 3, I add 6, and then I add 5. I can kind of stop right there. If it's not the same, this was 6 and this was 5, then this is going to be no. It's not an arithmetic sequence. All right. Try number 4 and 5. Determine whether those are arithmetic sequences or not, and then come back. So pause the video and figure it out. Okay, so number 4, if you looked, you added, and be careful, from negative 5 to 2, you added 7, then I added 7, then I added 7. So yes, it indeed works for all of them. My common difference was 7. And number 5, if you take a look, you're not going to be adding the same amount. If I go from 3 to negative 6, right, that gave me, I subtracted 9. But then I went from a negative 6 back to a positive, so this is definitely not going to work. It's not an arithmetic sequence. All right, number or letter B. Now, we're going to use formulas to help us generate arithmetic sequences and to be able to find future terms and prior terms. So if you look, what's really important that I want you to kind of, let's do this in blue. Your explicit formula is one that you're going to have to memorize. And the way you're going to have to start memorizing it is by putting the general formula down for every problem that asks you to do an explicit formula. What the explicit formula says, and again, it's to find future terms, meaning like if I asked you to find the 100th term in that sequence, instead of writing them all out, we have a formula that's going to get us to our answer more quickly. It says A sub n equals A sub 1 plus D parentheses n minus 1. N is the term number. Like, is it the 5th term? Is it A5? If it was A5, we would put n in here and here. Okay? A1 is our first term. So if you look, A1 stands for our first term. That's always going to go right here. Okay, it's first term plus, and the last thing that's in the equation is D, which is the common difference, right? Common difference is going to be whatever I'm adding or subtracting to get my pattern. Okay, so A sub n equals A1 plus D times n minus 1. And whenever you do explicit formulas, we're going to leave the n's in the problem. Okay, we're going to leave the n's in the problem. So we're really only plugging in for the first term and the common difference. For the recursive formula deals with finding prior terms. So meaning if I have like, the 50th term and I want to find the 49th term or the 48th or the 47th, okay, I'm finding prior terms. And this formula is A sub n is A sub n minus 1, meaning the term I want, I'm going to use from the term before it and then add the common difference, right? You also have to put what A1 is equal to, because in order to do the recursive formula, you're going to have to know what the first term is, right? So that is your recursive formula. So we're going to use those two and apply them to the examples below. So part C says examples using arithmetic sequences. Number 1 is 3, 5, 7, 9. So the first thing we want to do is figure out, first of all, if it is an arithmetic sequence. And if it is, we're going to find out what the common difference is. So if I go 3 to 5, I add 2, I add 2, I add 2. This is indeed an arithmetic sequence, and my common difference is 2. So what I want to do is I want to write the general explicit formula, A sub 1 plus D times n minus 1. Every problem, I want you to write that. Okay, write the general formula down. That's the only way you're going to memorize it, is by writing it. Let's plug in what we know. If you remember right above, we're going to leave all the n's because the n's are going to be what we use to predict later. So I'm going to leave a sub n. A1 is my first term. So if I go back and look, my first term was 3. My common difference we said was 2. And that's basically your explicit formula. However, what I would like you to do is I would like you to take that and simplify it. So what I mean is you're going to say 3 plus 2n minus 2. So my formula would really be 2n plus 1. Get it in simplified form because it's going to help us later kind of find an answer easier to a future term. So there's my explicit formula. A sub n equals 2n plus 1. And then I need to find the recursive formula. Well, the recursive formula is a sub n is a sub n minus 1 plus my common difference, and then I have to put my first term in. So I want you to write the general formula, and then underneath it, we're going to leave a sub n and a sub n minus 1. My common difference was 2, and then my first term was equal to what? 3. So this is the answer for my recursive formula. We're not going to apply the recursive formula in today's lesson, but we will in the future. So you really need to know how to find it so we'll be able to figure out problems using the recursive formula. All right? Now, part C says find the 32nd term. In order to find the 32nd term, that is a future term. So future term means I'm going to use the explicit formula that I found in part A, and I'm going to use that to find the 32nd term. So I'm going to say, okay, in part A, I found out my explicit formula is 2n plus 1. N stands for the term I'm looking for. If they're asking me for the 32nd, I'm saying, oh, A32. Every place I see an n, I'm plugging in a 32. I'm just going to plug in, where's that? A 32 every place that I see an n. So 2 times 32 plus 1. If you do 2 times 32, you get 64. If we add 1 to that, we get 65. Then I've just found out if I went out 32 places, the 32nd term in this sequence would be 65. All right, so let's do the same thing again on number 2. Let's go ahead and write the formulas down. So the explicit formula is a sub n is a sub 1 plus d times n minus 1. I need my first term and my common difference. So let's find out what our common difference is. Looks like you subtract 4, subtract 4, subtract 4, so it does. It indeed looks like it is arithmetic. It's a sequence, and my difference is negative 4. Let's plug in when we do explicit again. You're going to leave the n's and plug in for your first term, which is going to be 7, and your common difference. So my first term is 7. My common difference is negative 4. And technically that's good, but what I would like you to do, and we'll discuss this in class, is simplify that. So it's 7. If I distribute the negative 4, my final answer would be negative 4n plus 11. That's going to be my explicit formula. And I like it. The reason why I like it simplified is because when I go, let me jump to part C a minute. When I want to find this 32nd term, I need to use the explicit formula. So if I'm using the explicit formula and it's already simplified, I know I can find the 32nd term by just plugging in 32 for my n. Right? So it's nice that this is simplified as opposed to, you could leave it here, but then I would do 32 minus 1 times negative 4. It's very similar, but I'd like you to simplify it. Okay, so make sure that you're working on simplification of your explicit formula. If I solve part C, negative 4 times 32 is negative 128. If I add 11 to it, I'm going to get negative 117. So that means the 32nd term for the sequence in number 2, if I keep going out, would be negative 117. All right. Now don't forget part B. The recursive formula is a sub n equals a sub n minus 1 plus d. Put a semicolon. Okay. Then I need to put in my first term. So a sub n equals a sub n minus 1. My common difference again was minus 4. And then my first term was 7. So make sure you kind of box your final answer so I know which one's your actual recursive formula, your explicit formula, and your solution. Okay, I'd like you to try and pause the video and try number 3 on yourself. Find the explicit, the recursive, and the 32nd term. All right, explicit formula. Again, on your paper, on your notes, I better see that you're putting in the general formula because that's the way it's going to help you memorize it. To find the explicit formula, I need my first term and my common difference. So I have my first term. My common difference, if I look, I'm going up 4. So my common difference is going to be 4. Let's take that and apply it then to my formula. So a sub n, my first term is negative 9, plus my common difference is 4 times n minus 1. So a sub n is negative 9 plus 4n minus 4. So when I simplify that, it looks like I get 4n minus 13. That's going to be the explicit formula for problem 3. The recursive formula is a sub n equals a sub n minus 1 plus d, and I need to put down what my first term is. So let's go ahead and do that. I'm going to say a sub n equals a sub n minus 1. My common difference we said was plus 4, and my first term we said was negative 9. So that's going to be my recursive formula. And the 32nd term, again, I'm using my explicit formula to plug in. So I'm going to use from part A sub n equals 4n minus 13. And we're going to plug in, let me just put my charger in. We're going to plug in 32 for when we see an n. All right, so let's plug in 32. So 4 times 32 minus 13. I'm going to get 128. I'm going to come on over here. 128 minus 13. And so your 32nd term would be 115. Okay. Now, using those formulas and kind of our knowledge of arithmetic sequences, we're going to do the next couple problems on the next page. So if I scroll down, all right, it says find the 17th term given the following. All right, they gave me a sub 16 equals 12 and the common difference. If I know a sub 16 is 12, that means if I know the 16th term and I want to find out the 17th term, well, if the 16th term is 12 and they give me a common difference, if they're telling me this is an arithmetic sequence, then I know I use my common difference to add to get the next term. So if my 16th term is 12, if I want to go to my 7th term, I'm just going to add 5 to that and get 17. So this is kind of just thinking, hey, how do I use what they gave me? They gave me the 16th term, so to get the 17th term, I'm just going to add 5. All right. Similarly, on number 5, I want to do the 17th term when they give me, this time they gave me the 18th term and a common difference. So if I kind of write it out, here's my 17th term that I want. I know my 18th term is 8. However, when I do a common difference, that's adding to get the next term in your pattern. So I would add 1/2 to go forward. Like the next term would be 8.5. But since I need to go backwards, instead of adding 1/2, I'm going to subtract that common difference of 1/2. 8 minus 1/2 is 7.5. So my 17th term would be 7.5. All right, number 6 and 7 are kind of two-step problems. So this is what you might struggle with the most. So I'm going to do this step by step to make you understand it better. If I want to find the explicit formula for the following, and again, we're doing arithmetic sequences, I'm going to write down the explicit formula, a1 plus d times n minus 1. Okay? If I start filling in for this, again, I need my first term and my common difference. So I start doing this, and I say, wait a minute, I don't know the first term. I do know my common difference is 3. So I get this far, but I can't find the formula without the first term. Well, there's a reason why they gave me this, right? I'm going to have to use that to help me determine what the first term is. And I'm going to show you how you do that. I'm going to write the explicit formula again. But what I'm going to do is I'm going to use that A13 is 30, meaning wherever I see whenever I see an N, I'm going to plug in a 13 because I'm looking at the 13th term, A13. I don't know what my first term is. My common difference is 3. But now I know if I'm doing A13, that 13 is really what my N stands for. So if I simplify that, I have A1 plus, maybe 12 times 3 is 36. Okay, the issue is I still don't know what A1 is, right? In order to find that A1, I've got to know what A13 is. But that's why they gave me this. A13 is really equal to 30. They're saying the 13th term is really equal to 30, right? So if I put that in, and I subtract 36 from both sides, I'm able to determine what my first term of the sequence is. The first term is negative 6. But please be careful. Like I said, it's two parts. I need that first term to plug back in here, but then I need to use that to solve for my explicit formula. So 3n minus 3. If I simplify, I get 3n minus 9. So this would be the explicit formula if they give me a future term and a common difference. Okay, I'm going to practice one more of those again. So let's go ahead and look what they give me. I want to find the explicit formula given the following. I'm going to write down what the explicit formula is. I'm going to plug in. I don't know my A1, but my common difference they tell me is 15. So I say, hey, how do I find A1? Well, they're giving me this information for a reason. That's going to be useful for me to find my A1. So if I write the explicit formula again, and I plug in, okay, A12, meaning I'm going to plug in a 12. I'm going to plug in common difference of 15. Every place I see an n, I'm plugging in a 12. This would say A12 equals my first term plus 15 times 11 is going to be 165. Now don't get stuck here. I want to find the first term. I know what A12 is. I have to go back and look here, but my 12th term is really 197. So if I put in and substitute in 197, and then I subtract 165, let me kind of redo that. Let's take 197 and subtract 165, right? And that would get me my first term is going to equal to be 32. Okay, so if you subtract that guy over, I'm just kind of running out of room. So take what you found in the second part. I'm going to plug it in the first part to help me determine my arithmetic explicit formula. So 15n minus 15. So my a sub n is 15n. If I combine 32 and negative 15, I get 17. All right. The last part is I'm trying to find out blanks. So I'm going to use what we call the arithmetic mean. I want to find missing terms when I know it's an arithmetic sequence. The best way of doing that, kind of highlight it, is to find this arithmetic mean. What I'm going to do is I'm going to take the difference of the two numbers, the second minus first, over the number of jumps, right? And what that's going to give me is that's going to give me my common difference. And that's going to be a huge help because once I know the common difference, I can add or subtract to get my pattern. So let's look at number one. The only two numbers I know are 84 and 110. So if I want to find, let's say, this number in between, I'm going to say, okay, let's do 110. We're going to do the second number minus the first number, so 110 minus 84. And we're going to divide it by the number of jumps, meaning how many jumps did it take for me to get from here to here? Well, it took me 1, 2. Even though there's one space, it's 2 jumps. It's 2 common differences that I would need to get to that term. So if I divide that by 2, I get 26 over 2 is 13. That's going to tell me that my common difference is 13. So to fill out, I'm just going to erase the top of this so we have space. To fill out the rest of my problem, I know to get a future term I add 13. So if I start with 84, if I add 13 to that, I get 97. Now make sure this works out. 97 plus 13 better be 110, which it is. Then take 110 and add 13. You get 123. Right? How do I get the first term? Well, instead of adding, I'm going to take 84 since I'm going backwards, and I'm going to subtract 13 from it and get 71. And then everything should match up where I add 13 to get my pattern. All right, let's look at number 2. I'm going to take the second minus the first. I'm finding the difference of the two numbers, and I'm going to divide it by 1, 2, 3, 4 jumps. I took 4 jumps to get there. So if I do 24 minus 68, it's negative 44. Over 4, so my common difference is negative 11. So I need to subtract 11 to continue to get my pattern. So if I do 68 minus 11, that's 57. 57 minus 11, 46. And so on, be 35 and 24. And it does match up, so I know I've done it right. Okay, go ahead and try number 3 on your own. Go ahead and pause the video. See what solution you're going to get for those 2 blanks. All right, if you found the difference and did 23 minus 8 over, you went 1, 2, 3 jumps here. You're going to get 15 over 3, which is 5. So your common difference is 5. 8 and 5 is 13. 13 and 5 is 18. 18 and 5 is 23. So I know that I found the correct pattern. Okay, make sure you take a look at all those notes, write down what you need, re-listen to anything you need to listen to, and we'll see you tomorrow in class.